It's a beautiful day. Hi, ma'am. Hi, classmates. This is Rodgie Optional, ABS Ed Science 2 student. And today's video, I am going to discuss my chosen topic for our course. Talks about the Newton's law of motion. For the content, for the information of everybody, the content of my report is first the Newton's law of motion. Second, the actions at a distance forces. Then the last one is the application of the Newton's law of motion. But before anything else or discuss further about our discussion today, I have here Isaac Newton. Let's give him a short note. Newton was an English a mathematician, physicist, astronomer, alchemist, theologian, and author widely recognized as one of the greatest mathematicians and physicists of all time and among the most influential scientists. Newton's law of motion discussed each law of motion that Newton developed has significant mathematical and physical interpretations that are needed to understand the motion of objects in our universe. The application of these laws of motions are truly limitless, and essentially, these laws define by means by which motion changes, specifically the way in which those changes in motions are related to force and mass. So here we go. The Newton's first law of motion is stated that every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. So the Newton's first of law of motion simply discussed that when the object will remain at rest unless a net force is act on it. So as you can see in the picture, the ball is not moving or remain at rest because there is no force exerted or there is no force exerted in the object. That's why the object is remain at rest. So that's why the object is stayed in the same position. So that's the first law of motions discussed by Isaac Newton. So the Newton's second law of motion, a force causes usually only a change in velocity and acceleration. It does not maintain the velocity. So the Newton's second law simply discusses there is an acceleration, no? As you can see in the picture, and the man have a force exerted pushes the cord, yung box, no? Yung heavier na merong mga lamang boxes pa, um, more mass, sobrang mabigat siya, then merong accelerations na mangyayari because the man pushes the cart, no, na merong sulod na laman rather na mga boxes. That's why merong changes na nangyayari, ah, merong acceleration na nangyayari. That's why yung velocity ng isang object is hindi siya maintained because there is changes. That's the second law of motion. So the third or the Newton's third law of motion, for every action there is an equal and opposite reaction. As you can see in the picture, the man throw the ball, um and you can create the man create an action and reaction of the forces. As first, he hold the ball, followed by throw. There is an actions na nangyayari when yung ball is bumitaw na sa kanyang kamay, no? There is an reactions na nangyayari. So that's the third law, Newton's law of motion. So the action at the distant forces at this content, let's focus about mass and weight. Mass is a measure of the amount of the material in an object, while weight is the gravitational force acting on a body. For although for trading purposes it is taken to the mean and the same as mass when the force is measure when also the force is a measure of the interaction between bodies, and load usually means the force exerted on a specific surface or a body. So mass is a scientific measure of the amount of matter of an object is made of. So everything that there is matter no na mako-consider natin siya. No matter where you are at a given moment in time, mass is a constant. So, for an example, you are walking to the shop to stock up on the groceries or bouncing around the moon if you're a scientist, your mass is the same. But obviously, if you are in a diet, that is not the answer of you want to hear about. Do not panic. You will get to the all important definition of weight shortly. Some other key points about mass. First, mass in this is indestructible. So as you can see in above, no matter your where you are in the universe, your mass will never change. Secondly, mass can never be zero. What we meant by this is that everything in the universe has mass. If it didn't, it simply wouldn't exist. Third, mass is not related to gravity, centrifugal force, etc. And for these forces have no effect whatsoever on your mass. And lastly, mass is commonly measured in kilograms and grams. So now let's talk about weight. Weight is a form of measurement that is dependent on gravity, and unlike mass, your weight can vary depending on where you are in the universe. Weight is a pretty important measure not only to dieters the, the world over, but also the scientists and eggheads who design things like space shuttles and both opposite end of the spectrum, but it is all about perspective. So for the formula of the weight, for the information of everybody, weight is equal to mass multiplied by gravitational acceleration, or simply denoted as W is equal to mj, or mass and gravitational acceleration. So for the application of Newton's law of motion, this content talks or discuss the different three laws of motions and ano yung when it comes to applying, no? So here is number one. So for an example, an apple falling to the ground must be under the influence of a force. According to his second law of motion, that force is gravity, which causes the apple to accelerate towards Earth's center. For the second, Newton's reasons that the moon might be under the influence of Earth's gravity as well, but he had to explain why the moon did not fall into the Earth. Unlike the falling apple, it moved parallel to Earth's surface. So, number three, what if he wondered the moon moved about the Earth in the same way as a stone whirled around the end of a string? If the holder of the string let go and therefore stop applying force, the stone would obey the law of inertia and continue traveling in a straight line, like a tangent extending from the circumference of the circle. And four, but if the holder of the string did not let go, the stone would travel in a circular path like the face of the clock. In one constant, the stone would be 12 o'clock. In the next, it would be at the 3 o'clock. Then a force is required to pull the stone inward so it continues its circular path or orbit. Then the force comes from the holder of the string. So next, Newton reasoned that the moon orbiting was the same as the stone whirling around its string. Earth behaved as the holder of the string, exerting an inward directed force on the moon. This force was balanced by the moon inertia was tried to keep the moon moving in a straight line tangent to the circular path. And lastly, sixth one, finally, Newton extended this line of reasoning to any of the planet revolving around the sun. Each planet has inertial motion balanced by a gravitational attraction coming from the center of the sun. So those are the different application of the Newton's law of motion. So I hope learn of my short video discussing about the Newton's law of motion. And thank you so much for watching and listening, and have a nice day and goodbye to everyone. Bye bye.